All right, to begin with for this lesson 7-4, we're going to start off with what we ended our last unit doing. Okay, so they've given us a polynomial. Here's our polynomial. Last time we just wrote it as, they didn't write f of x, but this is our polynomial. We want to divide it by x plus 4. Since it's just a 1x to the first power, we can go ahead and use our synthetic division. So remember, synthetic division says you just change the plus 4 to a negative 4, and all you have to do is write all of these lovely coefficients. Okay, so I've got a 1x to the third, 1x squared, negative 4x, and 41. When I go ahead and divide this 1 is going to drop straight down right here. Negative 4 times 1 is negative 4. 1 minus 4 is negative 3. Negative 4 times negative 3 is 12. 12 minus 4 is 8. 8 times negative 4 is negative 32. 41 minus 32 is 9. 9 right here. Now, last time when we were doing the division, we'd go ahead and we'd say, okay, since this was an x to the third, we're going to put in an x squared, and we'd put some other numbers in here. However, this lesson we're learning what we call the remainder theorem. So all we really care about is this remainder right now. So we're going to look at this remainder and how it relates over here. So remember that you do this, but we'll do that. We'll put this back in next lesson. Again, this lesson, we really only care about that remainder, whatever that remainder is. So notice over here, they ask you to find something that we did a few years ago, even last year. They want us to find f of negative 4. So what this is really saying is if you have this function, they told me f of x equals this. So if I want to find f of negative 4, all I'm going to do is I'm going to replace my x with negative 4. So every time that there's an x in here, I just replace it with my negative 4. So I've got negative 4 to the third plus negative 4 squared minus 4 times negative 4 plus 41. All right, so that's what they're asking me to do. You could grab a calculator. It's going to be quicker if you grab a calculator, or we could just do this by hand. Negative 4 times negative 4 times negative 4 is negative 64. Negative 4 squared is 16. Negative 4 times negative 4 is also 16. Then plus 41. So that goes to 32. Negative 32 plus 41. This is going to equal 9. Oh, look at that. It is the same value as our remainder over here. Now, look as well. See that negative 4? That was the value that we used in our half box. So when we evaluated this function at negative 4, it gave us the same answers when we used negative 4 as our 0 and the remainder right here. And you're asking, is this just a fluke or does this always happen? Well, it is not a fluke. They want you to try one more. So now we're going to divide the same, different function. Here's the function. They want me to divide it by x minus 9. So again, I can use my synthetic division since it is a 1x to the first power. So we're going to change the sign, make it a 9, and then just write your coefficients. Now watch out for missing terms. I've got 7x to the fourth. I got negative 63x to the thirds. I don't have any x squareds, so I've got to put that 0x squared, 9x, and negative 80. Again, we're just looking for a remainder. So 7 is going to drop straight down here, multiply with 9, give me 63. Oh, we like it when it goes to 0. 0 times anything is 0, plus 0 is 0, times 0 is 0. 9 plus 0 is 9. 9 times 9 is 81. Minus 80 is 1. So notice right there, again, these numbers will play back into what we're doing next unit, but for right now, we only care about this negative 1. All right, now we're going to find, it's missing. We're going to find the value. Remember up here, we evaluated this function and what was in our half box right here. So we're going to evaluate this function at 9 that's in our half box right up there. So we're going to do f of 9 is equal to, every time that there's an x, we're going to plug in a 9. 7 times 9 to the fourth minus 63 times 9 to the third plus 9 times 9 minus 81. And we made a really yucky one just to show you that it's going to be so much easier to do it by our long division. than it is, or our synthetic division, than it is to do this by hand. I actually am just going to grab a calculator and put this in exactly like this, because I don't want to raise 9 to the 4th and multiply it by 7, then raise 9 to the 3rd and multiply it by this. So I'm just going to say, let's put this in the calculator, and magically, or mathematically, I guess I should say, it comes out to equal 1. Notice, again, remainder. Okay, so here is your theorem. This always happens. This is a nice, lovely theorem that you can use from here on out. And this is what it says. If you've got a polynomial function, they're just calling it f of x, but yours could be anything. If it's divided by some linear factor, we're just going to call it x minus c. I'm not sure why we call it c, but we call it c. So again, c can represent 9. It can represent -4. But if you've got some factor, then the remainder is f of c, f of when you evaluate it at c. Now notice again, this was x subtract c, and we evaluated the function at c. So if it is x plus 4, you're going to evaluate it at -4. So you're going to change that. And they call this, they have a nice lovely name for our synthetic division. When we use it to evaluate a function, they call it synthetic substitution. So we still get this synthetic word in there, but it's going to be substitution. Substitution. Let's spell that right. All right, so that's basically the rest of the remainder theorem, is that we're just going to use the remainder theorem to do our substitutions. We will do those in our next video.